Hello everyone. How are you guys doing today? Is it me or all of you are feeling cold? I'm feeling so cold. So today we are going to do week 9, even though we are on week 10. Did you guys go over identities like sum identities, difference, double angle, half angle? No. Oh man, what you guys on which section you guys are on, or which topic you're doing? Inverse. Hoping the inverse of sine and sine. Yeah, like the graphs. Inverse graph. Wow.
Like if you give out gradients with angles, they hurt from like cosine or pi or
I see those things. Okay. And Friday will be your last class, right, before the spring break?
Yeah. Or Thursday.
When is your class? Friday or Thursday?
Thursday. Tuesday.
Monday, Thursday.
Monday.
Okay. Okay. Um. Then what should I do? Week 9 or week 10?
Week 10 is further anyway, right?
Week 10 is completely different.
Oh.
It's algebra. Not algebra. Yeah, it's kind of algebra. I think I'll do week 10 and then you can do week 9 as a homework. Well, let me introduce you a little bit of both. Week 10 is solving system of equations, which you learn in algebra. So I'm going to go over that. But for week 9, it's all about double angle, half angle, sum angle, difference of angles, sum of angles, those. So you need to know all of these identities. So yeah, let me introduce you to the identities. You don't have to memorize them, I think, because they'll give you the reference sheet during the exam. But you have to know them. When they don't have to memorize them, but you still have to know them. Man, it is cold. So the sum identities means you are adding or subtracting two angles, and then you're applying the trig on the result. So if you have two angles, U and V, and you're adding them, you want to know what's the sum, what's the sign of the sum of the angles. The formula says, I hate the sound. The formula says, take the sine of the first angle, but cosine of the second angle. And then add the cosine of the first angle, and then sine of the second angle. So sine u plus v is sine u cosine v plus cosine u sine v. So that way I remember the identities are like this. Sine is very generous. So when you give it two angles, it take one and share another one with the cosine. So sine of one angle, cosine of the other angle. And then you add sine of the other angle, sine of the first angle. And when you take the differences, the same thing, you just subtract the result. The order, for the differences, the order does matter. Whatever angle is bigger, the first, your sine always has to get the first angle. So sine of the first angle, and then the second angle, you give it to cosine, and subtract the other way around. So sine is generous, okay? Anytime we give anything to it, it always shares with cosine. On the other hand, cosine is very selfish. When we give anything to cosine, it takes both of them and then whatever remains, it gives those to the sine. Also, it doesn't listen to us. We told them to, hey, cosine, add the two angles, but what it does, it subtracts the results. So for cosine, the formula is cosine A, cosine B, or cosine of the first angle and cosine of the second angle, and then minus sine of the first angle, sine of the second angle. Okay? And when we say, hey, cosine, subtract two angles, it actually adds the result. So cosine is always a spoiled child. It doesn't listen to anything. So it's selfish, spoiled brat, and everything. That's how you remember the formulas. And for tangent, as long as you find sine and cosine, double angle for the sine, double angle for the cosine, you can simply divide sine by cosine, you get the tangent. Or if you don't have to find sine and cosine, then you can simply use these formulas. And I don't remember the formula. I don't remember what is that. I always use sine and cosine to find tangent. Now for the double angle means the two angles we gave the sine here, they're the same angles, so it becomes double angle. So the result becomes 2 times sine of the angle, cosine of the angle. So again, sine is very generous. We gave 2 angle, but it becomes 2 times sine of the angle, cosine of the angle. On the other hand, if you give 2 angles to cosine, it produces 3 formulas. Any one of them is fine. My favorite one is cosine squared minus x. So cosine of the double angle is either cosine squared minus x squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. Any one of the formula is correct for the cosine double angle. For tangent, again, if you know the double angle of the sine and cosine, you can simply divide sine by cosine, get the tangent. Or if you don't have to find that, then you can simply use this formula. Again, I never memorized this one. Then you have half angle. For half angle means we are given an angle, but we want to know what is the trig result for trig value for the half of the angle we have. So if we get half angle to the sine, it gives 1 minus cosine of the full angle, and the result is going to be 2. So think about the 1 minus cosine of the full angle, and then to the square root. And you plus minus sign, you plus minus sign because depending on which quadrant you are on, we have either a positive result or negative result on one. So sign is positive on the first and second quadrant, right? So if your angle is lying on the third or fourth quadrant, you get a negative of the result. But if it lies in the first or second quadrant, the results will be positive. Now, if you get half equal to the cosine, the same scenario, depending on which quadrant you are on, you have either positive sign or negative sign. And see cosine also appreciation. We get half equal to the sign, it gives 1 minus cosine of the full angle. But for cosine, it's 1 plus the same cosine of the full angle. Cosine is always something. Want to share it with sign. Well, if you know how to use these formulas, that means you're ready to do week 9. So let's do some example on week 9. And then the rest you can fill out after you have your lecture on it. So I'm going to extend the time on Lumen. I'm going to change my slide. And we are going to do week 9. So we are given 2 angles. One is for the sine, one is for the cosine. And they want us to use sine with difference identities to get the exact value. It means we cannot use a calculator. We have to give them the exact number what we have for these angles. Let me do B. B looks smaller. So we are given cosine pi over 12. Unfortunately, I don't know what is pi over 12. What degree is it? So in my case, I always have to convert the radians into degree to figure out what angle we have. So we are going to convert that, right? Yeah. We have pi over 2. Sorry, pi over 12. I don't know how much that is. So I'm going to convert that into radians. So degree. So I don't want the radian. So put the radian on the denominator and 180 on the numerator. So I'm multiplying by the conversion factor so that I can cancel this and this. And 12 goes to 180 15 times, right? 12 times 15 is 180. Let me check, just in case. 180 divided by 12. Yep. That means we are given only the 15 degree. So 15 degree is lying on the first quadrant here. Our job is to find out what is cosine of the 15 degree without using any calculator. Since we don't know what is cosine of 15 degree, we are going to use two angles that we know the length of the angle. For example, which two angle can give us 15 degree? From 30, 45, 60, 90, those. 45 minus 30. So this is same as cosine 15 degree, which is same as cosine 45 minus 30 degree. So that means we have difference of cosine here. So difference of cosine, the formula is, remember cosine is selfish. So let me actually put it here so that I can have enough space. So it says it's cosine of the first angle and cosine of the second angle. And then we told it to subtract, but it doesn't subtract. It adds instead. So plus sine of the first angle and sine of the second angle. So that's the formula. Let me write down the formula for you. If you have cosine A minus B, A be their angle, this is same as cosine A, cosine B, plus sine A, sine B. And now we know what is 45 degree and 30 degree for sine and cosine. If you don't memorize them, no problem. We have our special triangles. One is 30, 60, 90, and the other one is 45, 45, 90. Do you remember the length of the 30 degree angle? How much is it? So opposite of 30 degree is 1. Opposite of 90 degree is 2. And then when you add them, we get 3. But since 60 is between these two, so we have to put it inside something. So you get square root of 3. What is the opposite length of the 45 degrees? No, the opposite of 45 degrees is 1. And the hypotenuse is 1 plus 1, 2. And then you take the square root. So you don't have to memorize anything, just to understand. So from here, we can find out all of these angles. Cosine 45 degree. So you go to the 45 degree here. Let me change the color. And cosine is adjacent over hypotenuse. So this is our adjacent and this is our hypotenuse. So we get 1 over square root of 2. Now if you go to the 30 degree, for 30 degree, our adjacent is here and our hypotenuse is here. So adjacent our hypotenuse is root 3 over 2. And you're multiplying them. Then we go to the sine. Sine 45 degree. So this is a 45 degree, sine is opposite of our hypotenuse. So 1 over square root of 2. And sine 30 degree, so if this is our 30 degree, our opposite is here. Opposite of our hypotenuse is 1 over 2. We add the middle and we multiply the individual length.
We do have to like this with the points on top, so I divide the bottom is 2. That's like square root of 2 over 2 or square.
So if you rationalize, this becomes square root of 2 over 2, and this becomes square root of 2 over 2. And we have root 3 over 2 here and 1 over 2 here. And since all of them have 2, so before even addition, we need to do multiplication. So in here, we have 2 times 2, 4 over square root of 2 times square root of 3. What do we get from square root of 2 times square root of 3? Square root of 6. So square root of 6 over 4. Similarly, here we multiply 2 times 2, we get 4, and square root of 2 times 1, that gives us square root of 2 over 4. Since we have the same denominator, so all you have to do is add the numerators, and we are done. We thought using calculator, you have no idea how much that is, but you don't care, because this is the exact result without any decimal point. Was there any part unclear? Did you guys understand what I did? Step 1, apply a formula. Either memorize or you don't have to memorize, but you have to have your formulas in front of you when you do them. So they give us half angle. So if they give us some angle, we have no idea what that is. So we use 2 angles that produces the given angle, and here is the differences. You can use, you can only use differences to get between. Use the formula, get the result for every angle from your triangles or from the table or from the unit circle. And then algebra, simplify. So you can do A by yourself later. You can also do question 2 later by yourself. Let me show you the double angle and half angle. So for double angle, you use the double angle formula. For half angle, you use the half angle formula. Okay. So all of these are based on formula. You're applying the formula. Question 3 says we have sine x is 1 over 8. X is in quadrant 1. So x is somewhere here. Use the double angle identities to find the sine double angle, cosine double angle, and tangent double angle. So they gave us this angle has opposite 1 and hypotenuse 8. So this is opposite and this is hypotenuse. So we can place them into the first quadrant with the opposite 1, hypotenuse 8. That means which side is missing? In this triangle, the adjacent. Can you find adjacent using algebra? Which type of triangle it becomes? Which type of triangle we have here for this x angle? What's the name of this triangle? Right triangle. So anytime you see a right triangle, which formula comes in your mind? Pythagorean formula. So let's say this is A, this is B, and this is C. So we have A squared plus B squared equals C squared. A and B doesn't matter, but C always has to be your hypotenuse, the longest side. So you have no idea what is A squared, but you do know our B is 1. So it becomes 1 squared. And our C is 8. So it becomes 8 squared. So we have A squared plus 1 equals 64. We subtract 1. So we get A squared is 63. But we are not looking for A squared, we are looking for A. So take the square root and we get A is square root of 63. It means the triangle we have for x, this side is square root of 63, this side is 1, and this side is 8. Well, why do we care? Because in order to find double angle for all of them, we need to use this formula. Sorry, not formula, triangle, to find out the length of each side of the triangle. So let's start with sine. Green, my favorite. Sine 2x. So remember, sine is very generous. Sine 2x means 2 times sine of the single x and cosine of the single x. So we go to each one of them. We get the result for each one of them from the triangle. Sine of x, they already told us here, so we don't have to find it. It's 1/8. But cosine of x, we need to use the triangle to find that out. Cosine is adjacent of our hypotenuse. So we get square root of 63/8. A nice algebra. 2 goes to 8 4 times. So we have square root of, let me share it here. Square root of 63/8 times 4, 32. So sine of the double angle for x is square root of 63/32. Then we do cosine of the double angle. Now cosine double angle has 3 formulas. It doesn't matter which one you use, you get the same result. My favorite one is cosine squared x minus sine squared x. It's my favorite because it reminds me of the sine square plus cosine square equals 1. So sine square plus cosine square is 1, but when you subtract cosine square minus sine square, it becomes a double angle for the cosine. So we go, which color? Now cosine square x, it means cosine x whole thing square. Cosine x whole thing square minus sine x whole thing square. And we already know cosine x. How much is cosine x? Square root of 63 over 8, so we're going to square that. And what is sine of x? 1 over 8. So we squared that quantity. The square root and square cancel out for the numerator, so we get only 63, and denominator square gives us 64. 1 square is 1, 8 square is 64. So what do you have total? 62 over 64. If you reduce, we get 31 over 32. So it's less than 1. So for tangent, we have to use any formula because we already have sine and cosine double angle. So tangent is easy. We are going to use whatever we have. Tangent to x is sine to x over cosine to x. You can use one of the formula tangent has, but I don't want to bother with that because I already have what I need. Change the color to blue. No, I already have blue. Purple. No, pink. So tangent to x, square root of 63 over 32. And we are dividing that by cosine to x, which is 31 over 32. The numerator is the cosine to x, the denominator is the cosine to x. So instead of writing numerator and denominator, I'm just writing it horizontally. So we do keep, change, flip. We get square root of 63 over 32 times 32 over 31. 32 is cancel out. We get square root of 63 over 31. Who is lost? Tell me why it's different. The main idea formula. I'm not doing anything but applying the formulas. So in our class, these things need to be remembered as formulas. And probably came late, right? So you didn't see the formulas. These are all the formulas for sum difference, double angle, half angle. I believe in your exam they will give you the formula, so you don't have to memorize them, but you do have to understand how to apply them. So for this one says we have sine of x is 1/8. Find the double angle for sine, cosine, and tan. So I went to the double angle formulas for sine, cosine, tan. And if you realize all of them has sine of a single angle, or cosine of a single angle. And they gave us sine of the single angle only. So we need to know what is cosine of the single angle. So for the given information, step 1, make a triangle so we can find out what is cosine of x. So they gave us sine is 1/8, is opposite of hypotenuse. So this is missing. We use the Pythagorean formula to figure out what is the missing part. Once you have a completed triangle, Now we know what is cosine and what is sine. Sine they gave us already, but cosine is adjacent of the hypotenuse. So from this angle, this is adjacent, this is hypotenuse. So square root of 63/8. And then the rest are algebra. Now the last one says, do not use calculator, but find the exact value using half angle identities. So we already found cosine 15 degrees in part A, question 1, but we use somewhat different identities. Let's just do the same thing for cosine 15, but this time using half angle identity. That means we need to go to the half angle identity sheet and see what's the formula. So here is the formula. Cosine of the half angle, depending on which quadrant you are on, you're going to get positive or negative sign. And then square root of 1 plus cosine of the full angle divided by 2. So what we do is we see we are given cosine of 15 degree. Good. So we don't know what is 15 degrees. So what we do 30 divided by 2. Because 15 degree is 30 divided by 2, half of 30, right? So half angle identity means find the angle, the half of that angle is the given angle. So 15 degrees given, 15 is half of what? Half of 30. So that means our full angle is 30 and we are taking half of that. So the formula, so 15 degree. 15 degrees in the first quadrant. In the first quadrant, is cosine positive or negative? Positive. So we are going to have positive square root of 1. I forgot, is it plus or minus? Cosine plus 1 plus cosine of the full angle and then divided by 2. So this is half. So this is theta. The angle. Nice. So basically we have square root of 1 plus cosine 30 and then the result we divide by 2. How much is cosine 30 degree? Square root of 3/2. We divide that by 2. Take the square root. Now if you don't simplify, you stop here. But if you would like to simplify, then you go into algebra. So you don't have to do that, but just for fun, let's simplify. We have 1 plus square root of 3/2, and we are dividing that by 2. Let me write it horizontally so that I have enough space. So in order to combine this, we need to have same denominator, so multiply top and bottom by 2. So we get 2 plus square root of 3. And we are dividing this by 2. So keep, change, flip. We get 2 plus square root of 3/2 times. When you flip 2, what do you get? 1/2. And now what do we have? 2 plus square root of 3/4. And remember, all of these are under big square root. So end result has a big square root. Oh, and square root of 4 on the denominator it becomes 2, right? Yeah. So we can do one more line. 2 plus square root of 3 divided by 2. So I'm not sure what your instructor will do. Would he require simplified version or not simplified version? So if he doesn't require simplified version, this is the answer. You can stop here. The answer is not simplified. And this is the most simplified one. It does look different than what we have in question 1. But if you put them in the calculator, you will see you have the same result, same number. It just looks different. Any question? So I left question 3, not 3. Which one? 2. Question 2 and 5 for you. These are very easy. And the rest we did together. So if you want, you can submit this Friday. But if you want, you can submit after 2 weeks. No problem. Once you remember, once you learn everything in your class, then maybe you can do it by understanding everything, and probably to be even more helpful to you. So anytime submit, no problem. I'm going to put the deadline after 2 weeks. But let me show you week 10 now. Now week 10, nothing to do with pre-calculus, okay? It's algebra. Wait, this was week 9. The one we did was week 9. What we're supposed to do in last week, but we didn't. And today you also didn't learn this. I don't know what it is doing. So today we're supposed to do week 10, and it's completely different than pre-calculus or trigonometry. It's simple basic algebra. So if you remember, you learned solving of system equations in your algebra class, and we had 3 ways of doing it. One is graphing, one is substitution, one is elimination. So let me write them down. 3 ways to solve system of equations. The easiest method is graph. Unfortunately, if you don't graph accurately, you don't get the correct result. So even it's the easiest, but it's the bad method, the worst method. The second is substitution. And the third is called either addition or elimination. I prefer elimination. So these are the 2 methods. If you forgot them, go refresh your memories about those 3 methods. Let me show you one from question 1 and question 2. So in question 1, we have only lines, system of linear equation. So all you have to do is find where do they intersect. And you have 3 ways of doing it. Let me see which button I want to do. My favorite method is elimination. So let me show you elimination method for B. So elimination method is called elimination because you want to eliminate one of the given variables. Either eliminate X or eliminate Y, it's up to you. But usually what we do is whatever is easier to eliminate, we eliminate that. Question of stretching. So in here, if you observe, the second line has 5y, but the first line has only 1y. So I can easily eliminate y if I have a coefficient negative 5y on the top one, because the second equation has already positive 5y. So you have to eliminate my y's. From positive 1y, I want to have negative 5y. So what can we do in the first equation? so that the y will turn into negative 5y. Great. So multiply the entire equation by negative 5. We have to multiply the entire equation because math is fair. If you multiply y by negative 5, you must multiply the x and also the number. So to multiply the entire equation. So we get negative 10x minus 5y. And what do you on the other side of the equal sign? 45. Since you're going to eliminate y, so it's called elimination method. And it also has another name, it's called addition method. It's called addition because in order to eliminate, you need to add the two equations. That's why it has another name, addition method. So when you add the two equations, the y's get eliminated. Now how many x we have? Negative 7. And what's the number we have? Positive 49. We divide by negative 7. So what is the x value? Negative 7. See? We could easily find one variable, we get to the another one. Now, solution means we need to have both x and y. We just found x, now we need to know the y. Can you guess?
Plugging the x into the equation.
Cool. Plug into any one of them. I prefer the first one because my y is already single here. So you have to get the y alone is subtract the 2x. So y is negative 2x minus 9. So negative 2 times negative 7, because we already found x is negative 7. And then it's algebra. Negative 2 times negative 7. And 14 minus 9. 5. So solution means where the intersect is negative 7, positive 5. That's all we have to do. I use elimination method, so let me write it down. Elimination. Now, in order to use elimination method, we have a condition. Both x and y have to be on one side. So say I choose elimination for the second one, because I already have x and y next to one another for both equations. Now, you can use either substitution or graphing method for a and c, and then do the same thing. If you cannot solve for x or solve for y, that means there is no solution, or they have infinite solution. If you're not sure which one you have, then you can graph and see which one you have, infinite solution or no solution. We get no solution if the two lines are parallel, they never intersect. We get infinite solution if the two lines you're working with are the same line. And we get unique solution means one solution when two lines intersect somewhere only once. So for B, we have a unique solution because they're intersecting only once at the x value negative 7 and y value 5. And the other two, find out what do you have, unique solution, no solution, or infinite solution. Any question? Now, let me do one from nonlinear. We have let me do D. D is the interesting one. We have x squared plus y squared equals 2, and y is x squared. X squared plus y squared equals 2. What is the shape of this circle? Good. So we have a circle and y equals x squared. What is the shape of this equation? Parabola. So if they intersect, probably we are going to have 4 solutions. If they don't intersect, then we have a circle here and parabola here. They don't intersect, something like that. So let's see what is the scenario. We have 4 solution or no solution. Or we may have 1 or 2 solutions. I'm not sure. So you have 2 ways of doing it. Graph them or solve them. Let me actually graph them because it's easy. For the first one, you have a circle. And what is the center of the circle? 0, 0. Because x and y, they don't have any number next to that. If you have a number next to that, then our center is at that point. So we have a circle, center at 0, 0. And what is our radius? Square root of 2. Whatever you have here, this is r squared. So r is square root of that thingy. Square root of 3 is 1.4, right? So this is 1 and this is 2. 1.4 is somewhere here. If this is 1, this is 2, 1.4 is here. This is 1, this is 2, 1.4 here. This is 1, this is 2, 1.4 is here. So we have 1.4 units to all direction. And then you connect them. It doesn't look like a circle, but assume it's a circle. And then we go for the parabola. It's a parabola. Vertex. Where is the vertex of this parabola? Good. 0, 0. So it starts from, let me pick different color blue. It starts here and go here and go there. That means we're going to have 2 solutions. Unfortunately, the graph doesn't tell us where the intersection are, right? So we just wasted our time. Let's do it manually. To find these 2 intersections, we are going to use substitution method because elimination doesn't work here. Substitution. For substitution, we are going to substitute 1 with another 1. So y is same as x squared. So this x squared, we are going to replace with the y. So we have y squared plus x squared equals 2. But this x squared is same as y, right? In the second equation, they're telling us x squared is the y. So we get y squared plus y equals 2. We subtract 2 from both sides of the equal sign. Y squared plus 2 minus 2 equals 0. And now it becomes quadratic equation. Most likely we can able to factor. 2 numbers multiplied to negative 2 combined to 1. Can you factor? Negative, positive 2, negative 1. 2 times 1 is 2. 2 minus 1 is 1. So we get y plus 2 equals 0. Gives us y is negative 2. Y minus 1 is 0. That gives us 1 is y. Now for each one of them, we know our y is x squared. So for y is negative 2, we get negative 2 squared, which is 4. For this y, we have 1 squared, which is 1. So the solution is a pair. What is the x here? For the left solution, x is 4, sorry, my bad, other way around. Sorry, I did something stupid. Yeah, I did something stupid. Y is x squared, so x is square root of y. right?
Then it can be only one, so it's exponential or negative.
So x is -2. So x is DNE, means imaginary. So we don't get any solution here. Here y is x squared, so x is square root of y and square root of 1. What is square root of 1? Plus minus 1. So the two solution we have is x equals 1, y is 1. X equals 1, x equals -1, y is 1. Because there are two x values, but a single y value. And see your two solution. So this point is -1, 1, and this point is +1, 1. It does make sense now. Two solutions. Go ahead. Okay, any other question? So next week we have spring break. We're not going to meet. We are going to meet again after 2 weeks. And in these 2 weeks, I expect you to do recitation 9 and 10. And you can submit after 2 weeks. The Friday after 2 weeks. So what's the date? Let me see. My touch is not working. Oh, it's working. You'll see the date on November. I'll change it later. Now, if you have any recitation to give me, you can submit now. If you don't have anything, I'll put everything on November. Who has the sign-in sheet? Sign-in sheet.
I just got one.
Really?
Yeah.
I got one last. Or whatever, I think it's Sp25. I was like, okay, back.
Yeah, no, I.
Dude, it was so bad, guys.